Hi, I'm Kim.
And I'm Marty.
Today we're going to talk about the Rainfall simulator, and I believe Marty's going to tell you a little bit about that.
I am. The Rainfall simulator can be modified to teach students anywhere from 3rd grade all the way up to high school, depending on the amount of discussion you want to have and the vocabulary used.
As with all SWAT kits that we have at the Denton County Master Gardeners Association resource room, the kit comes with a notebook that has all the detailed lesson plans that you as an instructor would need. You can also request for one of us to come out and give an in-person presentation. In the case of the Rainfall simulator, the only materials outside of the kit that you will need is some water to do the demonstration. I also suggest to you that it be set up the day before.
Before the demonstration, Kim, you want to make sure that all the tubs have the right vegetation for each demonstration and that it's set up properly. You want the tubs tilted slightly forward because it is a time constraint thing, and you want to have everything set up. It's going to take you about 45 minutes to get it all set up properly, so you really would better to have it set up the day before.
Outstanding, Marty, and good suggestions for the teachers. I would also remind all of the instructors who present this to remind their students that this is a simulation. And a simulation is a model for what happens in real life, but it is not exactly what happens. But this Rainfall simulator is a great way to teach young children, and again all the way up to high school, the effects that humans can have on pollution, soil health, and the environment. So Marty, are you ready to begin?
I am.
All right then. So Marty, first I'd like to ask you a question, and everybody out there a question. Do you know where Texans get most of their drinking water?
Well, Kim, I know that we get them from a couple of different places in Texas. Here in North Texas, we get them from the lakes. In South Texas, they have underground lakes called aquifers.
Outstanding. That is true. In North Texas, most of our drinking water and the water we use every day comes from what we call surface water, which is absolutely lakes and streams and rivers. But as you mentioned, aquifers are underground lakes. Did you know we could get our drinking water from under the ground?
Well, I did. I think it's interesting. I don't know how that works though.
Well, what happens is when rain falls on the surface, then it seeps into the ground. And when it seeps into the ground, we call that infiltration. We say that the water has infiltrated the ground. And when it gets into the ground, it can eventually seep a little bit into rivers and lakes, or it can go all the way down to the aquifers. And again, aquifers are where most Texans get their water.
So we're drinking dirty water in South Texas?
No, you would think so because it's going through all that soil, but that's not true, Marty. But that's a really good thought, and it's a misconception a lot of people have. What you might call dirt, we call soil, and soil can actually help filter water. So what it can do is it can hold on to microorganisms, it can help hold on to pollutants, and also aquifers are often lined with limestone, which can help filter the water. So the groundwater in aquifers is some of the cleanest on the planet.
That's really good to know.
It's pretty interesting, isn't it?
It is very interesting. I would have never thought that soil could actually filter water.
Well, it certainly can. And again, that all depends on the health of the soil. So today with the Rainfall simulator, we're going to talk about how rainwater gets into the ground and what happens to it when it lands on the ground. And to do that, we've got 4 different tubs that simulate 4 different types of soil. The first one, Marty, can you notice anything about the one that's labeled impervious surface?
Impervious. Well, first off, impervious means that your water's not going to be able to get through it. So what I'm noticing is we have a house, we have a driveway, the cars can drive on, and no plants. There's no soil anywhere.
You're right, Marty. You're very right. No plants. That was a really good observation. And also, you're noticing that probably water can't get into it, because that's what impervious means. Impervious means that the surface doesn't allow liquids to go through. Can you think of some things in your neighborhood that might be impervious surfaces?
Well, the roof of my house, my driveway, sidewalks, streets. What else?
Those are good.
I can't think of anything else in my neighborhood, but
Those
yes.
are really good. You might also see sometimes people put down plastic tarps. And so anything that water can't go through, including plastic, is considered impervious. And where we live has a lot of impervious surfaces. Now remember that where we live is part of our habitat, but it's also part of all the habitat for all the living things around us. Can you think about this situation and tell me whether you think areas with a lot of impervious surfaces are good habitat? And before you answer that, remember from things that you've learned in the past that in order to be a good habitat, living things need to live someplace that has shelter, water, and food. So do you think that impervious surfaces provide a good habitat?
Well, the houses certainly provide a good habitat for us, but not for anything in nature, unless they're living under the eaves, because I don't see any place that provides water or food, only shelter. And you need all three of those things, as you said before, to make a good habitat.
That's very correct, Marty. And so most of the time, places with impervious surfaces probably do have a little bit less habitat. Now, thinking about rainwater and what we talked about before when we considered infiltration into the ground, what do you think is going to happen if we make it rain on the impervious surface?
Well, we're going to have a lot of runoff, and I don't see anything that can give us the groundwater because it's impervious.
Absolutely, and I'm glad you used that word. Runoff, Marty, is when water cannot seep directly into the ground, again, infiltrate, and so it goes somewhere else. It's diverted somewhere else. And on an impervious surface, it's going to either be diverted into the street or it's going to be diverted down a hill. And so you might have noticed in your neighborhood maybe some storm drains. Have you ever noticed anything about storm drains in your neighborhood?
You know, it's funny that you mentioned that, because there's a storm drain right by my house, and the runoff runs off of my property. So I see the things that come off the street into my yard. And you know what, Kim? I have to clean a lot of stuff up.
Yeah, you do. And a lot of places, especially in areas of heavy construction, will actually put shields across the storm drains because there's so much waste in a construction area and so little plant life that there's a lot of runoff. Runoff, again, is when that water goes directly somewhere else instead of going into the ground. Runoff can contribute not only to pollution from things like oil from our cars, from things like fertilizer in our grass or chemicals and pesticides, but it could also be other pollution from just people walking by and dropping things on the ground or construction sites. That then can contribute to both pollution and erosion. So, thinking that then, that's a good hypothesis for impervious surface, and we'll test that in just a minute.
Kim, can you tell me a little bit more about erosion?
So erosion, Marty, did you learn about that back in school ever?
Well, I did, but I'm trying to think of where erosion would happen on an impervious surface.
Well, erosion won't happen as much on impervious surface, but erosion, Marty, if you'll remember from school, is any time something is taken away by a force of nature, such as wind or water. So you're going to get some erosion on some impervious surfaces, but as soon as that runs off of an impervious surface and gets onto the ground, especially if that ground is not protected by the roots of plants, then what happens is the soil gets carried away along with the pollutants, And again, our surface water runs into, if it doesn't infiltrate, runs into rivers and lakes. And then that can help pollute our rivers and lakes and can actually help make the lakes shallower because of all the sediment that runs down into them. Go ahead and go on to our next type of land, which is turf grass. And before we start with that, can you tell me what turf grass is?
Absolutely. Turf grass is the kind of grass that we plant in our yards. It gets into our gardens, as any gardener knows, playgrounds, golf courses, things like that. It's the beautiful green stuff that we like to mow.
Yes, turf grasses are very common in places where people like to spend a lot of time outdoors. Thinking about turf grass and what you see here, what do you think it would be as far as habitat? Do you think it would be a good habitat or a bad habitat for living things, and why?
Well, I think absolutely it's going to be a good habitat. I've gone out in my yard and I've actually gotten a magnifying glass and seen all the little critters that are in there. And actually, if you're out at night and you shine a light in your yard, it's going to look like little dewdrops, but they're actually little spider eyes coming back at us. So yes, it's a good habitat. They've got food, they've got shelter, and they have water.
Those are all good points, Marty. What I'd like to point out is that turf grass can be excellent habitat for living things, but it really does depend upon how the humans around the turf grass are using it. Because if there is a lot of foot traffic, then the habitat might get compacted. That means that so many people are walking over it and rolling things over it that the ground can become hard and pressed in, and that can actually keep water from infiltrating into the ground and can help it make more runoff instead. Also, human beings can pollute that turf, and they can put things like fertilizers and chemicals. So the amount of pollutants that people put on the turf and how much they walk over and cause compaction can limit how good a habitat turf can be, but turf can be good habitat. Now, with that in mind, if we cause it to rain over turf grass, what do you hypothesize might happen?
Well, depending on how hard the rain is and how hard it's coming off the impervious surfaces above us, we're going to definitely get some runoff because it takes time for the water to get into the ground. So I think we're going to see runoff and we're going to see groundwater.
Those are great observations and very good set of hypotheses. We'll test it in just a minute. Let's go ahead and move on to overgrazed rangeland. Now this is different from the other two types, so I'd like you to look at it and tell me what you see and what you know about rangeland that's been overgrazed.
Well, Kim, it doesn't look very healthy. I see some plants that have been chopped down pretty much, and it looks like they should be a lot longer. I don't see as many plants in there, so I see a lot more soil.
Very good, Marty. So rangeland that's been overgrazed, that means that livestock animals have come through and eaten more vegetation than the environment can sustain. In fact, some of those types of animals actually can pull the plants completely up by the roots. So as you observed, there aren't as many plants in rangeland. And again, depending upon how the people are using it, it might also have chemicals and pollutants in it. Now, thinking about rangeland that's been overgrazed, what do you hypothesize might happen if we cause it to rain over the rangeland?
Well, from what you've told us, and from what I can hypothesize, if you have a lot of livestock in one area for a long time and they're overgrazing, they're not only pulling the roots out and getting rid of that protection for the soil, but they're also compacting the soil. So I'm thinking that we're going to see a lot more runoff than groundwater.
You're probably right. We'll test it in just a minute. Again, another fantastic hypothesis. Also, I want to you to take a look at that and think about the habitat. Do you think rangeland is very good habitat overall for wildlife?
Maybe for some, but not for most. You can have some microscopic or some very small things, but it's not going to be a really good habitat. It can't sustain a lot because there's not that much there for food and shelter.
Absolutely. And again, that depends on the people. Some people can sustainably provide rangeland for their livestock and not overgraze it. But overgrazed rangeland, for the most part, is not usually great habitat for most living things. Let's go ahead and move on to our very last piece of land here, which is representative of native grasslands and native plants in general. Marty, what do you know about native plants?
Well, native plants have been around for years and years and years, and through adaptation to our climate, to our soils, to any myriad of conditions, the native plants can grow here pretty well without our help.
That's absolutely true. They don't need extra watering. They, as it says, are native, so they are, as you said, adapted to the environment. Something else that's very important about native plants and native grasses is they tend to get much deeper roots. So, for example, if we go back to turf grass might have roots that deep at their deepest. But native grasses, some native plants and grasses can get roots about as deep as I am tall. So what do you think that does for the soil when rain falls on native grasses? What do you hypothesize might happen there?
Well, for one thing, the roots are going to hold the soil, so you're going to have a lot less erosion, and it's going to help the water, I would think, trickle down or infiltrate deeper into the soil.
Marty, your hypotheses have been superstar hypotheses. Before we move on, talking about this native grass again, and thinking about habitat, what kind of habitat do you think native grasses are going to provide for wildlife?
Well, considering how many different types of native plants we have, I'm thinking you're going to have a lot of wildlife in there, and a lot of different kind of wildlife. You've got great habitat. You don't have a lot of impervious surfaces. You've got food and water.
Marty, these are good points, and I would like to point out something that you said earlier, that these have been around for many, many years. So yes, they do provide excellent habitat, because not only are the plants adapted to the environment, but all of the animals and other organisms that live in the area are adapted to those types of plants. So I'm going to agree with you about that habitat, and now it's time for us to test all of your great hypotheses. So Marty, what I'd like you to do is to reach around and get water. There are jugs of water here in the simulator, and we're going to pour the water one at a time over each of the tubs above our pieces of land, and we're going to simulate rainfall. Take that first jug, and before you pour it in, can you remind everyone about what your hypothesis was?
My hypothesis on the impervious surface is that since it is impossible for any of the water to infiltrate into the ground, we should expect a great deal of runoff. Now, what I'm going to do to simulate pollution is I'm going to put a little bit of soap on this impervious surface to see what it does.
And before we go on, remember that the soap is a simulation. So it's going to simulate oil from cars, fertilizer, chemical pesticides, and any other pollution that people might put on the ground in a real life situation. All right, Marty, go ahead and test your hypothesis. Okay. Go ahead and make it rain.
Here it comes.
Outstanding. Go ahead and adjust that bucket a little bit right here. Yeah, there you go.
And Kim, one thing I'm noticing is the difference in the rain coming down here. It looks like it's collecting on these gutters and on the roof and coming off a lot faster. So I've got a lot more water here.
Right. And can you notice what's going into the runoff? What's floating on top of the water in the runoff?
Well, Kim, as you say, we're simulating pollution, and the suds from the soap are all on runoff. And you'll notice, if I could show this to the camera,
Absolutely.
no groundwater
No
whatsoever.
groundwater. So Marty, is that supporting your original hypothesis?
It absolutely is.
And can you tell me, now remember we're talking about both surface water, lakes and streams that we get our water from, as well as aquifers when the water infiltrates. Is there a lot of infiltration or any infiltration that's being allowed with an impervious surface?
Absolutely none. And keep in mind, this becomes our drinking water.
In the lakes and streams where we get most of our water in North Texas. Great observations, Marty. So that's going ahead and finishing up. Let's go ahead and make it rain over turf grass. And before you do, can you please remind us what your hypothesis was for what happens to the rainwater when it hits turf grass?
I told us that I expect a little bit of runoff, but more groundwater. So let's try.
There you go. All right, Marty. Now you made a great observation about impervious surfaces. A lot of times, not only does it create runoff, but it causes the water to divert to areas that we don't intend it. And it happened in our model just here. So that was an unintended situation, but it's actually a very good simulation of what happens in real life. Now take a look at the turf grass. What's happening to turf grass that you notice?
Well, I have a lot of groundwater coming off, not a lot of runoff.
Not a lot of runoff. And is that what you expected?
Not, well, I guess yes, but if we had a violent rain and it wasn't filtering, if we had a downpour, I would suspect that we'd have a little bit of runoff with that.
You might, and this might be some turf that has been, not been compacted. All right, I'm gonna go ahead and make it rain on this side of the simulator. And before I do, we're going to talk a little bit about your hypothesis for overgrazed rangeland. Will you please remind us what your hypothesis was for the overgrazed rangeland?
My hypothesis is that we are going to get some groundwater, but we are also going to get some runoff.
Yes, we are going to test this now and see if your hypothesis is correct. And remember, teachers and students, it's more important to report what you see in your experiment than to try to make your hypothesis correct. Now, taking a look at this, what do you observe?
We have a little bit of groundwater, but you know, Kim, we have a lot more runoff.
We have a lot more runoff. Is that what you expected?
Yes, especially when we have violent storms that are so frequent in North Texas. I think if it were dripping down, it'd be great, but can you imagine if we had a downpour, what we'd have in runoff?
If it was on a large scale, absolutely, Marty. So again, did you support your hypothesis?
I think so.
Yes, I think you did. I think that this test supported your hypothesis. Let's take a look at the very last simulation, which is our native grass. So I'll pour the water in, and then you can tell me whether or not your hypothesis was supported. Pour a little bit more there. All right, Marty, taking a look at this simulation of rainfall, please tell us what you notice.
Well, I don't notice anything yet. It's taking a little bit of time for that water to do anything. Probably
Why do you
because it
think?
has to go through the grass and it has to go through the roots.
It absolutely does. And let's make sure that our tub is over there. Yes, and so we can edit that part. Yes, Marty, I agree. It's probably taking longer because of that good root system, which is exactly what we would expect. Good infiltration means that that water's going into the ground and not running off. And because is going into the ground and getting all the particles getting absorbed by all the things in the soil, it's going to take longer for groundwater to form. It's going to take longer for that infiltration to take place. Marty, I'd also like to point out while this is taking place, while we're waiting for our final observations, that native grass prairies are some of the most endangered ecoregions in the entire state of Texas. Because of construction and human beings taking over more and more of that land for their own use, we're actually losing a lot of our native grasslands, which means we're losing the ability for our soil in Texas to have the surface area for the rain to infiltrate and recharge those aquifers. So that's an important thing to note, and it's an important thing to consider. Are there any final observations you'd like to make, Marty, based on all of the situations that you see right here?
Well, absolutely. And I want to make a good point. You've made a very good point about us taking over and losing so much of the native grasses that are so important to our environment. If, in fact, this is what we need to go into the aquifers, and this is what we need to go into our lakes, the native grasses and the aquifers aren't filling up the lakes, and we're going to be short on water.
If we're not very careful in Texas, then we could become very short on water. We have a lot of people moving here. That doesn't mean we have to let ourselves get in a crisis, though. We can take care of the land. We can use water and our land in responsible ways so that it's here not only for our generation, but for future generations. Marty, is there anything else you'd like to add?
I would say that we need to maybe reconsider what we're planting, how we're planting it, and how we're using our water. And we should always think about water better.
Thank you, Marty. So today we've talked about water quality, the health of soil, and how all of this impacts our environment. That is the Rainfall Simulator Kit. I encourage each of you to go to dcmga.com, that's Denton County Master Gardener Association.com, and check out all of the other great SWAT kits that we have. Two of them that come to mind right offhand are Enviroscape, which is a simulation for older children and students that tells people how pollution actually gets into the water in more detail than this. And then there's one that's geared more toward younger children in elementary school called Freddy the Fish that does the same thing. But this and all our other great kits are available at our SWAT page, dcmga.com. Thank you. Thank you, Marty.
Thank you, Kim.